So as you see in this program, the recursion functions are basically similar, but what's happening here is the max level variable. So that's a global variable. That global variable is checked when the recursion goes to every single level. So what this if condition and the variable basically does is, it basically checks if the current node that's visited is the first node of that particular level. So if the max level is less than the given level, that basically means that the node we are currently present in right now is the first node of that particular level. If max level is greater than the given level value, that means that the node that we are currently visiting right now is not the first value at that particular level. There has already been a node that has already been visited before the current node. So that is what the if condition and the max level value represents. Take this example to find out the left view of a BST. So as you see in this given binary search tree, the values which will be printed as the left view are 10, 11, 28, 37, 25 and 38. So we'll now see if that is going to be the case. The program starts from the root node, which is at node 10. At node 10, the value given to the function, which is level, is 0. We check the if condition and we see if max level value is less than or equal to is less than level. Since that is not the case, the if condition is not satisfied. We again now go to the next node, which is node 11, using the recursion, and we pass the value of level as 1. So at 11, the value of level is equal to 1. So we have to remember one thing here. This is a call by value. The value to the variable level is passed using call by value and not call by reference. So this level value will be 1 here at this node and will be 0 here at this node. So I hope you know what call by level means. So at 11, the value of node the value given to the variable level will be 1. So we check the if condition and we see if the value of max level is less than level. At node 11, we check if the max level value is less than 11. Since that is the case, the if condition is satisfied and we print the 11 and we print the value 11 over here. So the first value that's going to be printed is 11 in the output screen. We now go back and the value of max level is also set to 1. So we now go to the left subtree of max 11 of the node level of node 11. Since that is null value, we again go back to the node 11. So we now go to the right subtree of node 11, which is node 28. At 28, we check the if condition. Well, at 28, the value that is passed in the recursion will be 2, which is level plus 1. So at node 28, the value of the variable level is equal to 2. So we now check if the value of max level is less than the current value level. Since that is the case, 28 will also be printed. 28 is printed and the value of max level is equal to 2. So I hope you get what's happening here. At every single node, we check if that node is the first node at that particular level. So we saw if the node 11 was the first node at this level. Since that was the first node, it was printed and the value of max level was assigned to the variable 1, and we went to this node and checked if this node is the first value at this particular level, which is the second level. So this is the 0th level, first level and second level. Since this node is the first value at this particular level, we are printing this value and equating the value of max level to the input that was to the variable level that was passed by call by value. So now max level is equal to 2. We now go back to the go to the recursion line and go to the left subtree of node 28, which is node 37. So at 37, and the value that is passed is level 3. The value at this node here is level 2, and when it's passed by call by value using the recursion, that's the value of level changes to 3. So that is what is happening here. So at 37, this is going to be 3. We now check if 37 is the first node at this particular level. Since that is the case, the if condition is satisfied. So if max level, which is 2, is less than the current level value 3, so max level becomes 3, max level is equal to 3, and 37 is equal to, and 37 is printed. We now go to the left subtree of 37, which is null, and we again go back. Similarly, we go back to the right subtree of node 37, and we pass the value to this node as level plus 1, which is 3 plus 1, 4. At node 25, the value of level is equal to 4. At 24, at node 25, we check if this value is equal to the current, is less than the, if we check if the max level is less than the current level value. Since that is the case, we print 25, we assign max level to 4, and we assign max level to 4, and we print node 25. So we now go to the next recursion call, which is at node 38, and the value that's passed to this level will be level 5. And since max level is less than level 5, max level is now going to be 6, max level is now going to be 6, and we print 38. So similarly, we go to the left and right, left subtree of 38, which is null, and we go to the right subtree of 38, which is also null, so we return, and the control now goes back to node 25. At 25, we have to remember that the level passed here was only through call by value, so the value of level will now be 4. So level is equal to 4, and we still go back to the right subtree of node 25, which is node 29. So at node 29, we check if the max level value, which is 6, is less than the current value 29. Since that is not the case, we come to the conclusion that the level at which the node, that is node 29, is present in, it has already been visited once. So there's also already another node which is before the node 29, and which has already been printed. Since that is the case, we don't print 29 here, so we go to the left subtree of 29, which is non-existent, so we return, and we go to the right subtree of 29, which is also non-existent, so we come back to 29. So the control now goes back to 37, and after going back to 37, we go back to 28. So at 28, we go to the right subtree of at 28, we have to remember that the value of level is going to be 2, because it was passed by call by value. The value of the level is still 2. We are now go to the right subtree of 28, which is 40. So at 40, we check if the current max level value is less than the value that is passed to node 40. The value that's passed to node 40 will be level 3, level that's passed to 40 is level is equal to 3. Since max level is greater than this level value, we know that there has already been a node that is present at this same level that's before 40. So we know here that 37 has already been before 40, and that has already been visited by the program. So 40 will not be printed. So we now go to the left subtree of 40, and since that's null, we come return and go to the right subtree of 40, and since that's also, and we go to the right subtree of 40, and before going to the right subtree of 40, we pass the value of level as 3 plus 1, 4. So at 40, we have level is equal to 3 plus 1, 4. So we check if the max level value at 34 is less than the current value of level at 34, but the max level value is 6 and the level value is 4. Since the value of max level is greater than the value at level here, we now come to the conclusion that there has already been a node in the same level as 34 that has already been visited by the program once. So that node is nothing but node 25. So the value at this node 34 will not be printed. So we go to the left subtree of 34, and that's null, so we come back. Similarly, we go to the right subtree of 34, that's also null, we come back, and the control goes back to 40. After going back to 40, it goes back 40, the node at program at for node 40 is over, So it passes the control back to node 28, and after going to node 28, the control at node 28 is passed back to node 11, and after going to node 11, the control is passed to node 10. So at node 10, we have the next line happening. So at 10, the value of level is going to be 0 since it's passed by call by value. So after becoming 0, we go to the right subtree of node 10, and at node 17, the value that's passed is level is equal to 1. So at 17, we go to the left subtree of 17. We check if the max level value is less than the given current value. Since it's greater than the current level value, we come to the conclusion that there has already been a node that's present at level 1 even before node 17. So that node is nothing but node 11. So that is what the number 6 that is what the value of max level represents. So we now go to the right subtree of node 17, and that's null. Similarly, we go to the right subtree of node 17, that is also null. So the control now goes back to the parent node of 17, which is node 10. So the final values that will be printed are 11 apart from node 10 are 11, 28, 37, 25, and 38 in that particular order. So this represents the left view of the entire binary search tree.